Alright guys, so today we're going to talk about still motion in one dimension, and we're going to talk about velocity, which is similar to speed. But when we talk about velocity, we're going to talk about speed plus direction. So when we discuss velocity, it does have the direction component. So velocity is a vector. Remember, vector has a magnitude plus a direction. So, for example, if you tell somebody you're going 60 meters per second, you're giving them your speed. But if you tell them that you're going 60 meters per second northwest, now you've given them a velocity. So as soon as you have that direction component, you provide a velocity. Okay, so when an object moves at the same speed in the same direction, the object has constant velocity. The only way an object can move at a constant velocity is when it is going in a straight line at the same speed. So the example I always give is you're in a car, you put the car on cruise control, and you go straight. That's the only time that you have constant velocity, because as soon as you change direction, you have changed your velocity. It's no longer constant. Okay, that was weird. I don't know why I did that. All right, and then velocity does have the same unit as speed, which is meters per second. All right, so let's talk about average velocity for just a second. Average velocity is defined as the change in position divided by the time during which the change occurred. So your equation is V for velocity equals the change. Remember that this triangle is really delta, which means the change in position or displacement divided by time. So V stands for average velocity. The typical unit is meters per second. Change in position or displacement. Remember, position, displacement kind of mean they are synonyms, so they mean the same thing. So final position minus starting position is how you find the change in position. That unit is typically meters. And then, of course, T stands for time, and that unit is seconds. Okay. Oh, this button. Okay, instantaneous velocity, that is the speed and direction of an object at a particular instant. All right, whereas instantaneous speed is just the speed of an object at a particular instant. And remember that that's the function of a speedometer in a car. All right. So the key here is the difference between velocity being speed and direction, whereas speed is just speed, how fast, no direction. All right, so a couple sample problems. Let's see. Tony has an electronic Thomas the Tank Engine. Thomas travels a distance of 0.75 meters in 15 seconds. What is Thomas's speed during the time interval? So we are looking for the speed of the tank engine. I'm just going to hit no there. All right, so let's see. We know that we're going to use, let's see here. Well, let's start. We have a distance of 0.75. So D is equal to 0.75 meters. We know that the time it takes is 15 seconds. And we are asked to find the speed. Okay, so the equation that we're going to use is S equals D over T. So S equals 0.75 divided by 15. So we're going to get that the speed is equal to 0.05 meters per second. Okay, the meters come from the unit for distance, and then the seconds comes from the unit of time. All right, pretty straightforward. That's a plug and chug. All right, so here we go with sample problem number 2. Miss Frere's dog Lucky escapes from the yard and runs into the neighbor's house. That's kind of funny. I just realized that says house. That's kind of weird. Covering 82 meters in 20 seconds. She then realizes she has not been fed and walks halfway back in 38 seconds. So apparently Lucky went into the house as opposed to into the yard, but whatever. Okay, so what do we need to do? We need to calculate her average speed, and then we need to calculate her average velocity. Just to keep things clear, let's go ahead and do a really simple diagram. So I'm going to put a little dot here that represents where Lucky's motion starts. So here at this blue dot, she runs. I don't want that to be an arrow. Oops. Okay, so she runs a distance of 82 meters. Then she realizes, oh, I guess I'm in the wrong house, and she turns around and starts to walk back, but she only makes it halfway. Maybe she thinks, you know what, I bet they've got good dog food there. And she stops to ponder what house she really wants to go to. Regardless, she only goes halfway back, so I'm going to take half of 82, so I know that this green segment is 41 meters. All right, so the first part that I need to solve is her average speed. All right, so remember that speed is distance divided by time. So the distance that Lucky traveled was 82 plus 41. So that was, 123 meters. And then the time that it took is the total time for her to go 82 plus 41. So that's going to be the 20 seconds plus the 38 seconds, which is going to give us 58 seconds. All right? And so we are looking for her speed. All right? So we're going to do S equals 123 divided by 58. And S is going to equal 2.12 meters per second. Okay? The meters comes from the unit of distance, and then the seconds comes from the unit of time. All right, so pretty straightforward there for part A. For part B, we want to know what is Lucky's average velocity. Well, remember that average velocity is the change in position over time. The change in position is going to be her final position minus her starting position. All right, so remember, Lucky started here at this blue dot, and we said that from this blue dot all the way to this purple dot, she went 82 meters. So her starting position had to have been at 0. Xi is 0. And we know that she ran halfway back. So since this green segment is 41, her XF is going to be 41 meters as well, because she's going to be 41 meters, that's where her motion ends, from where she started, when she stops to figure out what house has the better food, I suppose. All right, so XF is equal to 41, because she's 41 meters from where she started. XI is 0. So anytime you have a problem and they don't say the object or the person or whatever started at 5 meters, if they don't give you an initial starting position, you assign that starting position to be 0. Okay? And then the time that this motion took is the same time that it took for the speed to take place in part A. So the time is 58 seconds. Okay? So we're going to do V equals 41, that's not a 1, 41 minus 0 divided by 58. So V equals 41 over 58. And 41 divided by 58 is 0.71 meters per second. So you can see there's a pretty big difference between average velocity and average speed. And that difference is due to their definitions. Average speed is total distance divided by total time, whereas average velocity is change in position over total time. All right, so I guess I will see you tomorrow. Bye-bye.